So this section, what 3.5 is about, is trig equations. So now we're going to actually be solving trig equations. We're starting off pretty easy, like it says, it's the easy section. So they're basically just saying, hey, use substitution, meaning just plug it in, to see whether this x value is an answer. So we're going to start off, they're just going to give us the answer. Does that make sense? A possible answer. They're going to say, hey, here's an equation. Cosine of x equals root 2 over 2. In a few minutes, we're going to find the x values that make that true. Right now, they're handing it to me. They're saying, hey, the answer is pi over 3. That works, doesn't it? And we'll check. They might give us a false one. So does that make sense, right, what's going on? So I don't want you to be confused. So right here in the beginning, it's like if I gave you an equation, I went, hey, solve 2x plus 3 is 13. And you know how to solve that. It'd be child's play for you guys. But if I was teaching it to people that had never done this before, I might start off by giving them the answer, saying, hey, see if x equals 5 is the answer. And so what would you do to see if x equals 5 is really the answer? Yeah, just plug it in. Is 2 times 5 plus 3 really 13? Is 10 plus 3 really 13? Yes, it is. And if they had told me 4 or something and I put in 4, I would have got 8 plus 3 and I would have said, no, it's not. You know what I mean? Just a yes or no. They're just warming us up right now. So right now, you know, instead of having to solve this whole thing on my own, which we'll do in a couple minutes, they're just going to say, hey, is that the answer? Is pi over 3 the answer? So we just plug it in. We just say, I don't know. Cosine of pi over 3, is that root 2 over 2? What is the cosine? Pi over 3.
1 over 2.
Yeah, good job. Yeah, pi over 3 is 180. Remember, pi is 180. That's 180 over 3. So that's cosine of 60 degrees, huh? You with me? Pi over 3. Pi is 180. So 180, 18 divided by 3 is 6. 60 degrees. Go to the unit circle, your favorite thing. 60 degrees right here, right? And that's almost to 90, huh? Over a little bit, up a lot, right? Over a half, up root 3 over 2. Remember, small, medium, large, 1, 2, 3, right? So this is over a half, up root 3 over 2. This is cosine sine. So what's the sine of 60? 1/2. As Chanel already said, yeah, the sine is. Neither of them is going to be root 2 over 2. So this is no. This is not a solution. It comes out a half. It's not root 2 over 2. That'd be for the middle. That'd be like 45 degrees, huh? So that's wrong. That's not an answer to that question. We good there? All right, let's move. Here's an equation. Cosine x is sine 2x. Is x equals pi over 3. Is that an answer? Give it a try. Just plug in pi over 3 in both the places you have x there. Let's see what happens. See what you get. So you take that pi over 3 and you pop it in there and you pop it in there. So you get cosine of pi over 3 and sine of 2 times pi over 3, huh? Because that one's sine of 2x, right? Okay, and so you know pi is 180. So this is 180 over 3. This is cosine 60. And this is sine of double that, so that'd be 120, huh? Am I going too quick? So we're just plugging in pi over 3. Pi over 3 is 60 degrees, as you know. This is 180 divided by 3. So they're saying is the cosine of 60... is that equal to the sine of double that, the sine of 120? I don't know. Let's go to the unit circle. So 60 degrees, we just did that one a second ago. That's right here. 60 degrees, that's over a little bit, up a lot, over a half, up root 3 over 2. Cosine is the x, so it's half. So this side's a half, just like this side here is a half, just like we saw a minute ago. Now, what's the sine of 120? Where's that? Where's 120? Right there, huh? Just 30 past the 90, right? This is 90 straight up here in the middle. We good there? So 120 is just a little bit past. So it's right there. So it's back a little bit. So back a half, up a lot, right? Back a little bit, up a whole bunch. Is that getting too sloppy? Can you see that okay? So the sine, which one's the sine? The up. The sine is the y value, huh? So does a half equal root 3 over 2? No. These are both a no. We good? So just plug in. Everybody okay with that 120, right? Because 120 is just a little past 90. I didn't draw it very well. You know, it's supposed to be a little closer, I think. Kind of like right there. So it's only back a little bit, it's up a lot. Back a half, up root 3 over 2. And the sine is always the up. The cosine is always the sideways. The sine is always the up, huh? So no, the half is not the same as root 3 over 2. No. All right, well, enough with that. Those were 1 and 3 were no. We didn't do 2. Problem. Sine of x is root 3 over 2. Select the correct choice below and necessary fill in the box. Type an exact answer. Okay. So sine of x is root 3 over 2. So they want me to solve there for x. So find the x, find the angle whose sine is root 3 over 2. So here's our first actual trig equation. How do we solve a trig equation? How do you solve where x is in the angle slot? We don't know what the angle is, and they want us to find what angle has a sine that's root 3 over 2. What do you think?
60 degrees.
Is that the small, medium, or large? That's the large, right? So I'll do two things. I'll draw a unit circle for you, and then I'll show you the actual unit circle. So yeah, so they're asking where now sine is sine the sideways or the up and down? The up and down. So they're saying where is it up a large amount? Remember there's basically 3 dots in each quadrant, huh? Let me do that, remind you of that. There's basically 3 dots in each quadrant. Which dot or dots are up the large amount?
60 degrees and 120.
Those two. Aren't those dots up the large amount? Aren't those dots up the most of any of those? Now, if this said negative root 3 over 2, then I would pick these two down here because that would be down the largest amount, huh? Positive is up, negative is down, huh? Everybody with me on that? If they said cosine, what if they said cosine? The cosine sideways, I would say over. I would take this dot and this dot, the two that are over the largest amount. Or if they said negative cosine, I would pick these two, the two that are back the largest amount. Getting the idea on that? So they said positive and sine. So up, so it's this one and this one. What are those angles? 60 degrees, and this is 90 in the middle, 120. 60 and 120. Now, they want radian answers, so really it's going to be best just to use the unit circle. It'd be to say, okay, where is sine root 3 over 2? I mean, we did it all by hand. That was great and everything, but what you're going to really want to do, I'm sure, is just go over and say, okay, where is sine? Remember, it's cosine sine, cosine sine, cosine sine, cosine sine, cosine sine, cosine sine, etc. all the way around. Where do I see sine values, right? Where is sine root 3 over 2? Well, as we said, right here, and right there. Those two spots, yes, 60 and 120 in radians, pi over 3 and 2 pi over 3. We good? None of the other places has sine values positive root 3 over 2. These two places are negative root 3 over 2 for the sine values, huh? So these are the only spots, 2 pi over 3 and regular pi over 3. So x is 2 pi over 3, either order, regular pi over 3. Let me so far so good. You can put, maybe I should have put them in. It doesn't, the order really doesn't matter, but if it bugs you, I'll put it in that order, whatever. So there's the two answers, except what they want. Let me just separated. They want you to go plus 2n pi. Here, I'm not writing this out very neatly. Let me try it again. So x equals, so you take the first answer pi over 3 and the second answer 2 pi over 3, and then in both cases they want you to write plus 2n pi comma plus 2n pi. Now why? What is that about? There's the complete answer. What's the 2n pi thing about? Anybody know? What does that mean to go plus 2n pi? Anybody know?
Rotation, like
Yeah.
times to get there.
Yeah. Well, yeah. You're right. You're right on it, Chanel. Yeah. So this is 60 degrees. Let's just take one of them at a time. Let's just say, hey, the answer is 60 degrees is one of the answers, right? If you start here at 0 and you open up to 60 degrees, you open up to 60-degree angle. That'll be a spot where the sine, the height, is root 3 over 2, the large value, right? But not only 60, you could go all the way around 360 and 60, whatever that is, huh? You with me? You could do a full loop. You could do a full loop and then 60, and you'd be at that same spot. Or how about you could do 2 full loops and then 60, or 7 full loops, or etc. You could do any number of full loops and then 60. So it's not just 60, but 60 plus 360, or 2 times 360, or 3 times 360, etc. Right? It's 60 plus any extra full loops. You tracking with me? That's what 2n pi is, huh? Right? That's extra loops. Thank you. That's extra loops. Because what? Because what's 2 pi? That's 360, right? 2 pi is the radian for all the way around. Remember, pi is 180. So 2 pi, 180, that's 360. And what's with the n? N means any number of extra loops, right? N could be 1, n could be 2. Whenever we throw n in a math formula, we mean it can be any whole number. 1, 2, 3, 4. Meaning we could have 2 pi times 1 extra loop, 2 pi times 2, 2 pi times 3. So this is what we're always going to do for our answers, is we're just going to throw a 2n pi at the end. We're saying, look, you can stop at 60 plus any extra rotations, or 120 plus any extra rotations. That's what we're saying. These are all the possible angles, and it's really an infinite number of answers where you would end up at those two spots, right? At 60 or 120, pi over 3 or 2 pi over 3, plus any extra rotations on that. Winnie?
It's because they don't list a restriction.
Yeah. In a bit they will. Yeah. Yeah, that's right. Yeah, Wendy's right. In a few minutes, they're going to say, hey, don't give us those extra rotations. Just tell us the answers within one loop. But right now, they just said, all the answers, please. So we're like, okay, you want all the answers? It's 60 or 120 plus any extra 360s you want to take from those. That making sense? We good? Right? So like 420, for example. That'd be what, right? 360 plus 60, that's 420. That means 360 and 60. You still stop at this same point. The sine value would still be root 3 over 2. That is an answer. That's an x you could plug in. You could plug 420 into your calculator and take the sine, and you would get root 3 over 2. That's another x value that makes it true. So there's infinite answers. Just go to the unit circle. You guys have that thing, right? And I could probably just put it up right here. Probably the easiest thing to do. Just put it right there for us. So they're saying, where is cosine? Is question number 5. Where is cosine of x negative half? So just look at that unit circle. Remember all those spots as you go around. It's just cosine, sine, cosine, sine, cosine, sine, right? Fine. There's almost always 2 answers. Virtually always 2 answers. So find the 2 dots, the 2 places where cosine is negative a half.
And is this one of those ones that doesn't have a limit?
What's that?
It doesn't have a limit for the number of times it can.
Yeah, so this one didn't say, so we're gonna have to throw the plus 2n pi on there. Yeah. So as you look around, it's just cosine sine, cosine sine, cosine sine, cosine sine. Because I'm looking for where's cosine negative half? Right there. Right? 2 pi over 3. We good? Cosine's negative half. And where's the other place?
240.
Yeah, 240 right there. See how cosine is also? Right? So it's cosine first, then sine. Yep, those are the two spots. 2 pi over 3 and 4 pi over 3, huh? Those are our two answers, the two places where cosine is back a small amount. These are the two dots, right here and right here, that are back a small amount up a lot, back a small amount down a lot. They're both back a half, aren't they? They're both back the small amount. So 2 pi over 3 and 4 pi over 3, so we go back and go, okay, well, the answers are 2 pi over 3 and 4 pi over 3, but what do we got to tack onto the back? Plus any extra full rotations. Plus 2 in pi. Or 2 pi in. You can write that any order, doesn't matter. Things multiplied, order never matters, right? You could write 2 pi in, same thing. Is that good? Those two spots plus any extra rotations, at those two spots, the cosine will be negative a half. We're solving trig equations. Making sense? We're finding what x values you could plug in there, and the cosine of those angles will be negative a half. So the cosine of 2 pi over 3 or 4 pi over 3 plus any extra rotations. 0. All right, let me let you think about it. And you know what tangent is, right? Tangent is what over what? Sine over cosine, right? Tangent, sine over cosine. So we're really asking ourselves, where is tangent, sine over cosine, 0?
I think there might be some people that didn't get it.
Anybody not get their homework back? Thank you. It's there. Feel free to just let Wendy know. There. So so they're asking, where's tangent 0? Where's sine over cosine 0? What do you think? What do we do? So do we look for where they're like both 0? I mean, that's what I'm asking. Do you say where like both 0, or what do we do?
You want like a 0 over 1.
Yeah, only the top, right? The only way to make a fraction equal 0 is to make the top 0. Has nothing to do with the bottom. You clear on that? Right? Do you understand just that basic idea? If I said, hey guys and gals, I'm thinking of a fraction and it comes out 0. What does that mean? Top's got to be 0. Are you 100% clear on that? Does that make sense? You think, well, what if the bottom 0? You tell me. What if the bottom is 0? What's that mean? Undefined, because that's infinity, really. 0 goes into 7. So you know that 0 underneath is undefined. Yeah, that's not 0. 0 in the bottom of a fraction does not equal 0. It's undefined. It's infinity. You try to calculate to give you error. 7 divided by 0. Right? It means 0 in the top, right? And just think about real life. I said, hey, last night I had 0/3 of the pie.
You didn't have it.
Yeah, that's just a weird way to say no pie. You know that 0 in the top is just 0, huh? So let's get back to it. So when they say, where's tangent 0? What they're really saying is, where's sine 0? That's all it means, huh? If the top is 0, the fraction is 0. So where is sine 0? I see two places. Do you see two places?
I see 180 and 0.
Cosine sine, 0 right there, and cosine sine, 0 right there. Yep. So pi, and they always want the radian answers. Pi and 0. 0 and 180, yeah. So pi and 0. So that's our answers. So I'll go back here. So the answers are x can be 0, or x can be pi, and plus 2 in pi. Plus 2 in 2 pi and 2 in pi. Like that. Yeah.
On matrix style, it says the answer is n times pi.
Good. You already looked at it? I was about to talk about that. Good eye. Yeah, why would that be? So everybody good so far? I'm writing that out. I don't think they'll take that. Wonder if they would. Let's go back and look at the unit circle. So what are we saying? We're saying you can stop here or here plus any full rotations. Think with me for a second on that. We're saying as you're cruising around the circle, you can stop there at 0 or there at 180 or any extra full rotations of that, any extra full 360s. Well, do you realize there's a really quick shortcut way to say that? You could just say, look, start at 0 and just add 180. See, Wendy, thanks. Add 180 add 180, add 180. Right? You can just say start at 0 and add a half a circle as many times as you'd like. See how that's a shorter way of, a more simple way of saying the same answer? Does that make sense what I'm saying? I'm saying you can, we know our answer is 0 or 180 plus any extra full rotations. That's true. But a simpler way to say is start at 0 and just add 180 or pi, half a circle, half a rotation, as many times as you want. Once, twice, 3 times, as many times as you want, you're going to get them all. And you might wonder, why didn't we do that before? That wouldn't have worked before. Look back here. Like if when we were here and we were here on the last problem, there's no simpler way to say that because they're not exactly half a circle away from each other. You see the deal? That's what's convenient about this one. These are exactly half a circle apart. So rather than saying each one separately plus full rotations, just say start at the 0 and just add as many half rotations as you want. So when two answers are exactly half a rotation away, they shortcut the answer. So instead of saying all this, they say, look, just start at 0 and do as many half rotations. Now, how do you, as many means n. N is like, could be, 1, 2, 3, 4, 5, whatever. As many half rotation. What's a half rotation? 2 pi is a full rotation.
So 1 pi.
Just pi. And what's 0 plus anything? It's gone. It's just n pi. So with all said and done, the answer is n pi.
It'll take 0 plus n pi.
Well, okay. You guys know. That's great. So yeah, either one of these looks like it'll take either one of these. Does that make sense? Is that confusing? Do you see what we're saying there? So again, 2 pi is a whole rotation. That's 360. Pi is a half rotation. And whenever we throw n in front, n can be any number, 1, 2, 3, etc. So that's any number of. This means any number of half rotations. So start at 0 and do any number of half rotations. That's what this is. If I was to describe this to somebody, say, hey, what are all the dots? I'd say start at 0 and do any number of half rotations from there. And you'd be at the other places that work. Does that make sense? So when two answers are half a rotation apart, that's what we do. All right. Okay. So what are we going to do here? I'm going to solve for that sine theta like I would solve for an x. You know what I mean? Like, what if somebody gave me 4x minus 1 is 2x? I'm just calling that whole sine theta like x. See how that's the same equation where I've replaced the sine theta with x? Tracking with me? How would you solve that equation for x? What would you do? Do you remember solving for x in your algebra days? Those were the best days of your life, right? I'm just kidding. What do we do? What do you do when you have x on opposite sides like that?
You have to get them all on one side.
Yeah, get rid of one of them. There's a lot of ways to go. I usually just get rid of the lower one. So I would like subtract 2x. You don't have to. You can subtract 4x. That'd actually be a little quicker than what I'm doing. So either way, so you just basically got to get rid of one of them. You don't want x on both sides. Just get rid of one of them. So this would be 4x minus 2x would be 2x. This is 0. Go ahead and write 0. Keep the equal sign and everything. And then what do we do to get x alone? Move the 1 over. Yeah, when you jump something to the other side, it just changes signs. You okay with that? I'm really just adding 1 to both sides, right? I just like to do the shortcut where I just jump it, it changes to positive 1. Last step to get x alone? Divide by 2. So x is a half, right? So let's go back and do that same thing now for sine theta that we did for x. So what's my first step on solving, trying to get sine theta alone? I want to get the sine theta alone. Yeah, get rid of one of them, right? You don't want them on both sides. So yeah, if you want, what you can do? How about this? How about I just do the jump thing? Maybe they'd be either just jump this one this way and jump that one that way. How about that? When things jump to the other side, they switch the sign in front of them because you're adding or subtracting that thing, right? So what do we get? We get 4 sine theta minus 2 sine theta is positive 1. Is everybody okay there? Right, when things jump to the other side, they switch signs. And then what's 4 sine theta minus 2 sine theta? Just do sine theta. It's like 4x minus 2x, huh? That good there. And then, to get sine theta alone,
Divide by 2.
divide by the 2. So, sine theta is a half. So we're down here now. We still have to do more though. Now that we got to there. So how do we solve for theta there? Now we go to the unit circle, don't we? We want to find the places where sine is a half. So let's go there. To the unit circle, our favorite trig destination. So we want to know where is the sine of theta half. There should be 2 spots. Do you see them? Right here, cosine sine, sine's a half, and
5 pi over 6.
right here, cosine sine, sine's a half. Pi over 6 and 5 pi over 6. Sine is up the small amount, isn't he? So we go, okay. So theta is pi over 6 and 5 pi over 6. Now, are those exactly half a circle away? No. We can't do the trick. That'll be very rare. We just throw in the plus 2 in pi, plus 2 in pi, and we're done. So everybody good with how we solved that equation? So we did some kind of x solving at first, and then we went to the unit circle. We just found what angles you could plug in to this for theta into that original equation and make it true. It's kind of surprising. We can solve trig equations now. Some of them. We'll do more and more. Questions? Good? Says something a little different than the other ones did. What do I mean? It says only in the interval 0 to 2 pi, please. They don't want all answers. They only want answers within one rotation. Right? 2 pi is 360. So saying, hey, just give me the answers between 0 and 360. See what they're saying? So they don't want the 2 in pi thing. In the end, we will have to use it halfway through, and I'll explain as we go. But in the end, there'll be no 2 in pi. Because they don't want to know about extra rotations. They only want answers between 0 and 360. 0 and 2 pi. Solve the equation on the interval 0 to 2 pi. Only answers between 0 and 360. Notice they put a bracket at 0 and a parenthesis at 360. Why? Why don't they put a bracket at 360? Because 360 is the same spot as 0, isn't it? And they don't want to list it twice. That would be the same spot twice. Right? 360 is all the way around. It's back to 0, isn't it? So there's no repeating. If they put remember, parenthesis means you don't quite hit it. Remember what that means in interval notation? Do you know that? Maybe I should say that first. So if you're at a bracket, that means straight on. Yeah, maybe. That means straight on the 0, right on the 0. 360 with the parenthesis means you're just close to 360, but you don't hit it straight on. You just get close to it. So, yeah, they're saying all the answers between 0 and 1 full rotation. See on number 7, if you go back, they just said, all solutions, please. All solutions. So that's why we had to add the 2 in pi on number 7 and all the ones before it. They just said all solutions. That means any extra rotations, we want them all. But now they're saying just within 0 to 360. Okay, so anyway, how do we do it? So cosine of 2 theta. The real trick, here, let me rewrite it for us. The real trick is that 2 theta thing. Cosine 2 theta is root 3 over 2, as we'll see. Okay, anyway, let's go to the unit circle. Find out where cosine is root 3 over 2. We certainly want to start there. So where is cosine 2 theta root 3 over 2? It's cosine sine, so cosine's the first one. So cosine sine, so that's cosine. So pi over 6, 30 degrees. Cosine, and where's the other one?
11 pi over 6.
Yeah, right here, cosine sine. Cosine is also root 3 over 2 at 11 pi over 6 and pi over 6. Good so far? Those are the two places where cosine is root 3 over 2. Pi over 6 on pi. Now, what does that mean? That means, think with me on this one. It's always best in math, it really makes sense instead of just just imitating myself, is really getting why I'm doing what I'm doing. So that means if I was to take the cosine of either one of those angles, pi over 6, I would get root 3 over 2, or 11 pi over 6, right? So that means if the inside of the cosine's like a function. I always make a toaster as my analogy. Toaster means if you put pi over 6 into the cosine machine, out will come root 3 over 2. Or if you put in 11 pi over 6, out will come root 3 over 2. So that means 2 theta. The inside of the cosine machine can be pi over 6 or 11 pi over 6. See how we have a 2 theta in there now? That's really the major difference on this question. That's going to mean a big deal, actually. See how on the last problems, look back at the last one. See how they were all just regular theta, regular, that's the same problem. Regular x, and regular x. They didn't put 2x in there, did they? So that's actually kind of a big deal. It's going to make it a big pain, really. So, all right, so what do we have so far? We have 2 theta, the inside. 2 theta can be what? Pi over 6, or, now you write it side by side. Follow what I'm doing. You'll see why in a minute. Or 2 theta is 11 pi over 6 plus 2 in pi. Now, I know you might think, Mr. Aaron, we said we didn't have to do that. We do for a special reason. I'll show you. So just write that out for starters. You track with. Normally we would just be done at this point, wouldn't we? We would just say, well, the answers are pi over 6 or 11 pi over 6 plus 2 in pi. Put a comma between them, done. Why is that not the case here? Why don't I just put a comma between those, done? How is that not answering their question now when it used to be before? What's different?
There's a 2 in front of that theta.
Yeah, because this isn't theta yet. This is 2 theta. I don't have theta yet. I've got 2 theta. Because they stuck 2 theta inside, not just theta, or x, right? So first off, I got to divide by 2. I'm not done because I got to divide by 2. Now, why am I doing the 2 in pi thing? Why don't I just take pi over 6 and 11 pi over 6 and then just divide them both by 2? Well, because it's tricky. There's extra answers. Why don't I just show you? Probably this is the case where it's best if I just show you what to do, and then after we're done, we'll look back and we'll talk about why that was actually right. So let me just show you what you do. You do write the 2 in pi, even though you think, yeah, but they said no extra rotations. I know. We're writing the 2 in pi for a totally different reason this time. It's because they put a 2 theta. Whenever they put 2 theta, 3 theta, 4 theta, something in there other than plain theta, you have to write 2 in pi, even if they only want answers in one rotation. You have to. So you write 2 in pi. Now let's finish it up. How do you get theta alone? You divide by 2, right? I'm going to divide by 2. Wait, is that yeah, let's divide by 2. Divide by 2. And so now how do you just go like divide by 2, divide by 2? Yeah, you could. I mean, that's true. That's right. But what would be an easier way of dividing pi over 6 by 2? That's kind of weird looking. Just multiply the denominator by 2, right? That's how you divide a fraction by 2, is you multiply its denominator, right? Denominator, if you multiply the denominator, you've divided. So, you guys with me? So theta will equal pi over 12, right? Pi over 12 plus the 2's cancel here in pi. Let me hold up there a minute. Am I going too fast? You tracking with me? So we went to the unit circle. We found the 2 spots, pi over 6, 11 pi over 6. We write the plus 2 in pi because of the 2 theta. That's really why we're doing that. Now, both those are equal to 2 theta because that's the inside of the function, the toaster. Divide by 2. We get to here now. Can you do the other side? Divide the other side by 2 also. Divide all 3 of those by 2, which means do the denominator, right? So we go divide by 2. Multiply denominator by 2, divide by 2. Cancels. Theta is 11 pi over 12 plus n pi. Theta is 11 pi over 12 plus n pi. Are we good so far? Now, where do we go from here? You basically have to let n you start with n equals 0 to n equals 1, and that's as far as you're going to need to go. Yeah, you do n equals 0 and n equals 1. And then over here, you're going to do n equals 0 and n equals 1 also and plug them in. I know this probably seems really mysterious. Let's just do it first, then we'll go back and we'll see why it worked and why it's true. So if you take this expression and you plug in 0 for n right there, what are you going to get? Pi over 12 plus 0 pi is pi over 12. Whoops, so I should have been a 12 there, huh? And then the second one, pi over 12 plus 1 pi. Yeah, that's a mess, isn't it? How do I do that? How do I do pi over 12? In fact, I better move it up and get a little more room here. How do I do pi over 12 plus 1 pi? What do you do? How do you add those together? How do you add when you have a fraction and a whole number? Do what's that? Common denominator, huh? You all know that. Common denominator. Put this over 1. Multiply top and bottom by 12. It's pi over 12 plus 12 pi over 12. It's 13 pi over 12. Is that good? There? And then we got to do the same thing on the other side. We got to take this formula, plug in 0, plug in 1. So when we plug in 0, (11 pi over 12 plus 0 pi is 11 pi over 12. And when we plug in 1, 11 pi over 12 plus 1 pi. And in order to add those, same kind of thing, huh? We have to get a common denominator over there. Right? Multiply top and bottom by 12. So that'll be 11 pi over 12 plus 12 pi over 12, which is what? 23 pi over 12?
Was 11?
Those are our 4 answers. Those 4 things I have circled, those are our 4 answers separated by commas. So the answer here, I'll put it up here. So the answer is, it doesn't matter what order, pi over 12, 13 pi over 12, 11 pi over 12, and 23 pi over 12. Any order. Those are the 4 answers. I haven't given a lot of reasons why. Yeah.
Why do you have the 2n pi?
Yeah, I'll try to give some reasons why. But first off, are we okay with just the process? Is it making sense what I did? Well, okay, so if I was you, I'd be wondering, like, whoa, what? This problem went kind of crazy. And it did. And what is it that made it go crazy? It's the 2 theta thing. So when you have to do this whole gigantic thing, we're going to have a whole bunch of them on Wednesday. When you have to do this whole gigantic thing is when they give you not just x or theta or whatever in the parentheses, but 2 theta, 3 theta, 2x, 3x, whatever. Then you have to do this whole complex process. What do I mean? You have to, after going to the unit circle and finding your spots, pi over 12 and 11 pi over 12, or I'm sorry, pi over 6 and 11 pi over 6, then you have to, throw on the 2n pi's, divide by 2, and then you got to get 2 answers, because the 2 theta means there's going to be 2 answers. If they did me 2 answers for each, coming out of each original. So 2 out of the first answer and 2 out of the second. So 4 answers altogether.
So if there was a 3 theta, we would have done 0, 1, and 3?
0, 1, and 2. There would be,
0, 1, and 2.
yeah, there would be 3 answers out of each side. Yeah. So we'll do some more on that. Yeah. Now, are those all really answers? Yeah, they actually are. All those, notice all those are less than 2 pi. All those answers are less than 1 rotation. How do I know? Well, 2 pi is 24 pi over 12, isn't it? Isn't that 2? 24 divided by 12 is 2. So see how they're all lower than 24 pi over 12? So they're all less than 2 pi. Those are all within 1 rotation, aren't they? Those are all less than 360. Now, why do you get extra answers with the 2? It's because it just works. You can see it if you put in the pi over 12, for example, to check it. What would 2 times pi over 12 be? 2 would go into 12 6 times. It'd be pi over 6, which is one of our answers, huh? See how that 2 would cancel these denominators, taking them back to something that works. All right, so let me write that out. So here's the deal. When you have 2x or 3x inside of a trig function, you what do you have to do about that? You have to take your, let's just say your 2x or whatever, equal to answer 1 plus 2 in pi, and 2x equal to, here, let's go with the 3x option since I just did 2x. 3x equal to answer 2 plus 2 in pi. And then you got to divide through by your 3 to get x alone. Answer 1 over 3 plus 2 in pi over 3. Divide by 3. Get x alone. And then you got to let n be 0, n be 1, n be 2, up to 1 less than original. What do I mean original? The original 3. N equals 0, n equals 1, n equals 2. There's the game plan. That's what you always do whenever they give you like a 2x or a 3x inside of a trig function. Everybody see what I'm saying there? Everybody see about the n thing? You always go up to one number lower. So if you started with 3x, go up to 2. If you started with 10x, go up to 9. Get the idea? Or another way you could say it is, there'll be the same number of answers as the thing. So if there's 3x, there'll be 3 answers because you start at 0 and go up to 1 less than the number. 3 answers out of each side. So 6 answers altogether. So whatever the number is of the 3, so if you had 4x, there'd be 4 answers coming out of each side. 0, 1, 2, and 3. 0, 1, 2, and 3. Getting the idea on that? And they're all valid answers, all within 1 rotation.
I was just looking at the unit circle, and basically, what I was figuring out was, like for the cosine, it's the same point, just on opposite sides.
What do you mean?
Well, like, was the one that they gave in Math Excel, it was -1/2. So cosine -1/2. So that's 2 pi over 3.
Right. Oh, yeah.
4 pi over 3.
Right, you're just noticing the symmetry, huh?
Over 5 pi over 3, and then up to pi over 3.
Over here and there. Yeah. There's this beautiful symmetry. You're starting to notice what we're going to get to in it's chapter 5. Yeah, something called de Moivre's theorem, and it'll show that it takes the whole thing and breaks it up into even sectors in a certain situation. Yeah, there's some beautiful symmetries here. That is true. Good observation. All right. Okay, so there it is. You see the 4x thing, so you know the whole process. So start by just going to the unit circle, though. Just go to the unit circle. Find where cosine is -√3 over 2. Get your 2 answers. Then you know what to do from there, right? give you. So where is cosine negative root 3 over 2? Right here, cosine sine, cosine, and 7 pi over 6 cosine sine. So 5 pi over 6 and 7 pi over 6. So there's your two values. So you start with 5 pi over 6, and then over here, 7 pi over 6. I'll let you take. We good to there? Oh yeah, guess we already have that, huh? Yeah, so now let do the end thing, right? So that's going to require fraction works, a little bit of pain. So n equals 0. That one's easy. The 0, just the back thing drops out, huh? So you just get 5 pi over 24, first answer, right? That's the easy one. Next, let n be 1. Probably only going to have room for a couple of these. So you get 5 pi over 24 plus 1 pi over 2. Good to there so far, right? Is plugged in 1. And so now I got to get a common denominator there, don't I? So what am I going to do to get a common denominator? By 12 over 12, huh? So this will become 5 pi over 24 plus 12 pi over 24, which is 17 pi over 24. So that's the second answer. I got 2 more to go on that side. Probably going to go to a fresh screen to do the other 2. Right, good so far. Can you get the next 2? On that side, then you got 4 on the right side. So n equals 2. 5 pi over 24 plus 2 pi over 2. That just cancels, huh? And so, well, I don't know. We don't really want to. I shouldn't have done that. We don't want to cancel right now. We want to make common denominators. Just leave that sitting there. What are you going to multiply top and bottom by to make the bottom 24? 12, yeah. So just do that. You don't really want to cancel anything. You want to build up common denominator. So you get 24 pi over 24, which what is that? 29 pi over 24. There's the third answer. And now n equals 3. 5 pi over 24 plus 3 pi over 2. Again, we want common denominator. So multiply top and bottom by 12. And we get 5 pi over 24 plus 36 pi over 24. That's what? 41? Whoops. 41 pi over 24. That's our fourth answer. We good to there? And now we got to get 4 on the other side. So on the other side, what do we have? The other side, we're going to let n equal 0 again. That's the easy one. That just means the back part drops out, so 7 pi over 24, and then let n be 1. And I'm going to get 7 pi over 24 plus 1 pi over 2. You've got to multiply top and bottom by 12. What do you get? 7 pi over 24 plus 12 pi over 24. What's that? 19 pi over 24. We got to get 2 more. Let's keep going. N equals 3. 7 pi over 24 plus 3 pi over 2. Top and bottom by 12. That gives us 7 pi over 24 plus 36 pi over 24, which is, what's that, 43? 43 pi over 24 and 1 more. So n equals 4. No, what? Oh, I just did 3. What did I do? I'm getting off and being crazy. Ugh, these are long, aren't they?
You could keep that answer.
I could have, but it's bugging me that it's not orderly. So I should have done 2 here. Why didn't you guys say something? You just watched me do that whole thing? All right. You probably didn't notice. 12 there. All right. And then 7 pi over 24 plus, so what's that? 24 pi over 24. Add that up. What's that? 31 pi over 24. And now the last one, which I actually did already. 3, not 4. Right? 7 pi over 24 plus 3 pi over 2. And multiply top and bottom by 12 to get one last common denominator. This whole thing just got terrible, didn't it? This section. 36 pi over, I'm getting tired of this problem, over 24. 43 pi over 24. There we go, 8 answers. Yeah. You want to do 3 more of the same thing. No, I'm just kidding you. Kayla, that isn't what you wanted to say. Go ahead.
So we don't pre-reduce until, like, let's say at the very end, if we have an answer that's reducible, we can reduce that.
Yeah, at the very end,
But
yeah.
not in the process.
Well, you could do it in the middle. Like I could have canceled earlier, like right here, but it would just make more work for you because you have to then multiply. So it's not that it's illegal. It's just it's not the quickest thing. You know what I mean? Yeah. So yeah, at the very end though, you do need to reduce if it can be reduced. Yeah. We got 8 answers, 4 out of each side, right? These 4. Right, this one here, this one here, this one here, this one here, and this one here, this one here, this one here, and that one there. 8 answers. Just as easy as that. There'll be like 12 of these on the next exam. I'm just kidding. Is that good? Are we okay with that? Like you know how to do that? Process, as messy as it is. Right, try that one. So now notice that one's not sine or cosine. It's cotangent, so you got to write the fraction, right? So go ahead and write the fraction. Do what we did before. And then how does a fraction equal 0 if the top is 0? Bless you.
Can we convert this to tangent?
I wouldn't. You could, but no big advantage. So what is cotan? What over what? Cosine over sine. Right, because it's upside down of tangent. So, okay, so how does a fraction equal 0? If the top is 0. That's the only way you can ever make a fraction 0, is if the top is 0. So basically, this question is cosine of 3x is 0. Forget about the denominator. Does that make sense? It all just boils down to the numerator. The bottom doesn't matter. They might as well have, instead of saying cotan, they might as well have just said cosine is 0. Because that's the only way cotan is ever going to be 0 because it's a fraction and the top of the fraction has to be 0. Tracking with me? So now just solve this problem. Where is cosine of 3x? 0. Go ahead and go to the unit circle. We'll go there. Right, y'all with me so far? So we make that a fraction. The only way a fraction zeros at the top is 0. Where's cosine 0? Good, yeah. Cosine sine right here. Cosine is 0. And right down here, cosine sine. Cosine is 0. Cosine is 0. Pi over 2 and 3 pi over 2, huh? So take those back. You know what to do. So 3x is pi over 2 or 3 pi over 2. Plus 2 in pi plus 2 in pi. So I'm going to divide through by 3, which means multiply the denominator and divide there. So x is pi over 6 plus 2 in pi over 3. Good. And then divide by 3, which means multiply the denominator by 3. So these cancel here. Pi over 2 plus 2 in pi over 3. So I guess I did reduce those fractions right away. Did cancel those 3's. So that's good. Yeah, so we reduced fractions. So we good to there. So now we got to take those two versions and we got to plug in 0, 1, and 2 for each of them, right? Because we have 3x, 3 answers out of each side, 0, 1, and 2, 0, 1, and 2. Okay, so now we let n be 0, and we just get pi over 6. That one's easy. And then we let n be 1, and we get pi over 6. Those 6's, bless you.
Thank you.
We good? Pi over 6, 5 pi over 6. What's that going to be? Is that 9 pi over 6? Yeah, and then you got to reduce that. So here we go. So here's like Kayla's good question. Yeah, if they're reducible at the end, you got to reduce them. So everybody see, because this is 1 pi plus that's 8 pi. I'm kind of running out of room there. 9 pi over 6, and then divide by 3, top and bottom, huh? Divide by 3. 3 pi over 2. How are we doing? Then the other side, can you get the 3 answers out of the other side? Plug in 0. Plug in 1. Oh yeah, that's a good one. Okay, so now we're here. I'm going to have to get common denominator. Am I racing ahead of you? How are you? You guys okay with those first three answers? With those? So right here, I'm at this point. I plugged in 0. That was simple. Plugged in 1. I need to add those up, which requires common denominator. What am I going to do? 6, right? So this time I have to multiply both fractions, aren't I? Good? Yeah.
Wouldn't it be faster or easier if you just kept it as 3 pi over 6?
Oh yes, if you just made that first one 3 pi over 6. Totally, that's what I'm going to do. Yeah. Yeah, if you just know that right away, you're right. Guillermo, right? Guillermo?
Yeah, well, because when we first got them, it was 3 pi over.
Oh, was it? Yeah, that'd be great if you're looking ahead and remembering that. Do that. And then the second one, I'm going to multiply by 2 top and bottom. So 3 pi over 6 plus 4 pi over 6, right? Is 7 pi over 6. There's our second answer, or our fifth answer. Second on this side. And then one more. These are so long. N equals 2, which means you go pi over 2 plus 2 times 2 pi over 3. I'm going to run out of room here, I think. Pi over 2 plus 4 pi over 3. I totally am. Pi over 2 plus 4 pi over 3. Just squeeze it over a little bit. Same kind of thing, common denominator. Going to have to multiply top and bottom by 3 there, top and bottom by 2 here. And so what will we then get?
4 pi over 6.
Is that what it is? Yeah. 11 pi over 6, because it's 3 pi over 6 and 8 pi over 6, which is 11 pi over 6. How are we doing on these messy things? Questions I can answer. Yeah, question?
So after we find all of the ends, like what is like the main answer that Canvas is like looking for when we finish this?
Yeah, it's just, so I'll write it out. So the answer would be to this question, just all 6 of these with commas. So pi over 6, 5 pi over 6, 3 pi over 2.
So we list them?
Yep.
Okay.
All of them with commas. And then just keep going. The other 3. Oh no, we don't have pi over. I thought we already had that. Pi over 2. Pi over 2. 7 pi over 6. And 11 pi over 6. Yeah. It takes a while just to type in the answer.
Doesn't matter what order we put it.
No, any order. Any order's fine. We good? How many of these you want on the next exam? What are you thinking? More than 5 or less than 5? I'm
They're
just
time
kidding.
consuming.
They are. Even if you know exactly what you're doing. They just take forever, don't they? Yeah. All right. Let's do on this one. Let me let you try. So go to the unit circle. Find where cosine, I'm going to pop up the unit circle here. Find where cosine is -1. I'll put it up here for you. Cosine of theta over 3. There's a question, right? Yeah. So find out where cosine is -1. This is going to be kind of it's not long, but it's a little different, a little curveball at the end here. All right, so first off, where's cosine -1? Just one spot. So remember I said it's almost always 2 spots? Well, here's why I didn't just say always. Almost always, because here's a case where there's only one spot. There's only one place where cosine is -1, at pi. It's very rare. That might be the only one I can think of. Anyway, so let's go back to, so it's only pi. There's only one answer coming off the unit circle. That's very rare. It's almost always 2. So that means, now, what do I set equal? I set the inside. That means the inside is pi. Are you with me? Right? Because that means you've got to make, that we know that the cosine of pi is -1. So the inside has to be pi to make that thing true, doesn't it? Right? We're saying what makes that thing true? Well, if you make the inside of cosine pi, he'll give you back -1. If you put -1 into the cosine toaster, he'll pop out -1, right? So that inside, that theta over 3, has to be -1. Okay, great. So what? Well, don't worry about the 2 and pi. Let me just write a note. When you have theta over a number, do not worry about the plus 2 in pi. Not needed. I'll give the reasons later, but for now, I'm not going to go the plus 2 in pi thing. Not needed. Don't worry about it. It's only when it's a number multiplied, right? Like if it was 3 times theta, or 2 times theta, or 4 times theta. But if it's theta divided by a number, don't worry about it. Don't need it. Okay, so what? I'm still supposed to solve for theta. So how do I solve that little equation there for theta? Theta wants to be alone.
You multiply by 1/3?
Um,
Or, 3 over 1.
yeah, multiply by 3. Both sides? You all good with that? 3 over 1, it cancels. Good. Theta is 3 pi. Now, is 3 pi the answer? Sorta. Which means no, not really, but it's really close. Why not? What have we done wrong? Now, why is this one not the right answer? Well, look what they said here. Give me an answer between 0 and 2 pi.
Okay, so can we put...
Yeah, no, so that's the right spot. We just have to say it like they want it said. So let's find it. Where is 3 pi? All the way around is 2 pi.
Yeah, and then it goes like...
So 1 more pi right here. This is 3 pi, isn't it? Because every time you go halfway around, that's a pi. That's a 180, right? So that's 1, 2, 3 pi. So it's right here, but what's the other way to say that spot? Pi. That's just regular pi. That's the answer they want. Now, I still don't know how to solve the other one. I want to go back and do it with you, though. But I'm good. Does that make sense on this one?
You can't solve the other one.
Confused about what I was confused about. Why can't you just go there and say, well, that's the same as pi? Yeah, that place is the same as pi. Yes, that's true. But pi is not an answer to the original question. Look back at the original. What if I made that top pi? Right? That's the final authority. Does it make it true? Is cosine of pi over 3 -1? No way. Pi over 3 is like 60 degrees. That's not -1. So the real answer is 3 pi, right? Go back here. If I made that top 3 pi, 3 pi over 3, the 3's would cancel. It'd be cosine of pi, and that is -1. But they're not allowing me to give that answer because that's more than 2 pi, because they said only give us answers between 0 and 2 pi. So if the answer you get is outside of that region, you say no answer. You can't give them pi. Even though you say, yeah, but pi is the same spot. Yeah, but in the original, it's got to be divided by 3, so pi isn't going to work. It's the same spot in the end, but that doesn't work in the original. Yeah, Kayla.
Since we only have 0 to 2 pi
Yeah.
available to work with, so anything over that is no solution.
Exactly. And because, now if they said any answers are possible, then 3 pi would be great.
Less than 0.
But they said, no, only give us answers between 0 and 2 pi, please. So our answer is more than 2 pi. The only answer is more than 2 pi, so no answer. Let's do that other one. Now I understand. Good, I'm learning today too. Cosine of, what was it? 2 theta over 5, was it negative?
Yeah.
Oh no, just regular is -1. Yeah, so can you solve that one real quick? So here's the other version, the one I got. Do the same thing. Where's cosine -1 on the unit circle? Pi. It's right, same place. You know, where's cosine -1? Cosine -1 right here at pi. So that means the inside must be pi, right? The inside of the toaster has to be pi, so that the cosine of pi will be -1. So then solve for theta there. How do you solve for theta? It was negative, wasn't it? Anyway, how do you solve for theta there?
No, no solution.
Come on, guys. We gotta first get it, and then we'll say no solution. You gotta multiply by 5 halves, right? The upside down to get theta alone, and then that's 5 pi over 2. There's an answer. What's wrong with that answer?
Because it's saying that it equals
Good.
-1, and it can't equal -1. It has to be between 0 and 2 pi.
Oh, no, you're getting confused between the angle and the answer. The answer is -1. The angle has to be between 0 and 2 pi. Tracking with me? So look what's this.
Why do all of them say there's no solution?
So this is the angle. So this is -1. We got -1 a few minutes ago, right? Even on one where they said 0 to 2 pi.
Right, and when you put it in, it says B, no solution.
No. I'm talking about, let me show you. Like that one. How about number 9? See, they wanted 0 to 2 pi on this one. It's off the screen a little bit. And then it's negative. But there were lots of answers. So no, don't get confused between the angle and the answer. They're saying the angle has to be between 0 and 2 pi. The answer may be -1 at certain angles. So the problem we're having is this angle. The reason this is no good is because what is 5 pi over 2? It's more than 4 pi over 2, which is 2 pi. That's more than 2 pi.
Okay, so what you're saying.
That's 2.5 pi's. 5 pi over 2, what that is, that's 2.5 pi, right? That's 5, if you multiply that out, it's 5 pi over 2. So if the angle comes out more than 2 pi, if the only answer comes out more than 2 pi, then throw it away. No answer, because they said we only want angles, please, between 0 and 2 pi. That's the issue. Make sense? We good?